This is how you simplify fractions using prime factorization. And what this will allow you to do is take a fraction such as 30 over 42 and finding the greatest common factor, which is in this case 6. And when you divide this out, you get a new fraction, 5 over 7. And this is what we call a simplified fraction. It means the biggest number that could divide into 5 and 7 is only 1. All you need for prime factorization is a list of the prime numbers. Here's a list of the first 20. And once you have your list, these are the numbers you're going to use to figure out what can divide it into the number that we are trying to simplify, or the fraction. So let me just show you what I mean. I want to show you two different methods, the factor tree and upside down division. These are just two different ways you can organize your work. Earlier I showed you that the greatest common factor for 30 and 42 was 6. So I'm going to show you how I got that. I'm going to use a factor tree to write the prime factorization for 30, and then I'm going to use upside down division to find the prime factorization of 42. And again, you can use either method. Just choose the one you decide is better for organizing your work. If you're going to use a factor tree, I'm going to start off by figuring out what in that prime number list divides into 30. And since it's even, I know 2 goes into it. So I'll write down 2, and then I'm going to write down what times 2 gives me 30, which in this case, it will be 15. And out of these two numbers, since 2 is prime, I'm going to circle that. 15 is not in the prime number list, so I'm not going to circle that one. So I go back to my list, and I say, okay, which one of these numbers goes into 15, which I can see is 3. That's the next number on my list. So that's divided by 3. In other words, 15 divided by 3 is 5. So 3 times 5 is 15. 3 is prime, so I'm going to circle it. And in this case, 5 is prime, so I'm going to circle that too. And once you see that all your numbers are circled, you can stop. Your prime factorization is done. So now I know that 30 is equal to the product, or in other words, multiplying these three numbers together. 2 times 3 times 5. All these multiplied together gives me 30. Now I'm going to do the prime factorization of 42 using upside down division. I know that 42 is an even number, and I know that 2 divides into any even number, so I'm going to divide this by 2. And the way I'm going to do it, I'm going to set it up like this. It's called upside down division because you're pretty much doing the division algorithm, but upside down. So I know it's divisible by 2, and 2 goes into that 21 times. So that is my prime number, so I'll leave that there. And then 21, I'll ask myself, okay, what prime number goes into 21? Since I know 21 is not prime, I know one of these has to divide into it. And in this case, I know 3 goes into 21. So I'll divide this up again. 3 goes into 21 7 times. So I'll put that answer here. And I know that 7 is prime. And since 7 is a prime number, then I stop dividing. So underneath it, I could organize it by saying 42 is equal to these numbers here. So 2 times 3 times 7. 2 times 3 times 7. Now that I have my prime factorization for 30 and 42, the last step is to look at my fraction. So it was 30 over 42. And I know I can rewrite this as the product of 2 times 3 times 5. That's what we had earlier. 30 is equal to 2 times 3 times 5. So I can say that that is equal to this. And my denominator, 42. 42 is the same as 2 times 3 times 7. So I'll write down 2 times 3 times 7. And now, when you're simplifying fractions, all you're really doing is eliminating common factors. So you look at your fractions, and anything that matches in the numerator and denominator, you can cross it out. Because, for example, in this case, 2 divided by 2 is just 1. So when I cross this out, all I'm really saying is that this is just 1 over 1. And the same thing for 3 and 3. I could cross that out and get 1 over 1. Because, again, 3 divided by 3 is just 1. So 1 over 1 is the same answer as 3 over 3. So, again, cross out anything that's in common in the numerator and denominator. And whatever is left, that'll be your simplified fraction. So that's how I got earlier that 30 over 42 is equal to 5 over 7. So let me know, which method do you prefer, factor trees or upside down division when it comes to organizing your work for prime factorization?